Hello, this is Dr. Strickland. In this video, we will investigate comparison of means with the student's t-statistic. Take a minute to read through these student learning objectives. These are the things you should be able to do by the end of this video so that you're ready for the more difficult things we will do together in class. Now, the t-test is the second part of the analysis that we started with the f-test. Okay, so come here first. The t-test can be used to compare the means of two sets of measurements to decide if they're statistically different or not. If there is less than a 5% chance that the difference between the means of two similar data sets arise from random error, then we have a more than 95% confidence that the two means are actually different. Okay, so we're going to have a calculated t-value and then a reference one that we look up in a table. And it's the same kind of comparison as we did with the f-test. If the calculated one is less than the table value, that tells you one thing. If it's greater than the table value, that tells you something else. So if it's less than the reference value, the data sets are not statistically different. And you can be sure that they're identical data sets. Then if the calculated value is greater than the reference value, the data sets are statistically different. So if you're talking about results from two methods or results from two different instruments, that's the kind of comparison that you would need to do. Now, at this point, there are two possibilities. When you run the f-test, it may be that the two standard deviations were not statistically different, so that they were the only differences that arose had to do with random error. There is a second case where the two standard deviations are statistically different, and we'll deal with that later. But this one, first things first. Okay, so when the two standard deviations are not statistically different, then they can be combined to form a pooled standard deviation. And then the pooled standard deviation is used to calculate the t-statistic. Okay, so a pooled standard deviation has an equation that looks like this. Big old square root symbol. So we have the variance from the first data set times its degrees of freedom plus the variance of the second data set times its degrees of freedom, all divided by the total degrees of freedom, n1 plus n2 minus 2. And then all that is within the square root symbol. All right, so this can then be used up here to find the calculated value for t. So what we need is the difference between the two means. And we're going to put an absolute value symbol around it so the difference is always positive. And this is divided by this pooled standard deviation times a factor that involves the count of the two sets, multiplied on the top, added on the bottom, and you take the square root of the whole thing. Okay? So these are the equations that you need to know to calculate the t-statistic if the two standard deviations are not statistically different. All right, so come on down here. We're going to put this in motion. A reliable assay of ATP involving 4 replicate measurements in a certain type of cell gives a mean value of 111.0 micromoles per 100 milliliters of solution with a standard deviation of 2.8, same units. You've developed a new assay, which gave the following values in replicate analyses. There are these guys right here. This data set has a mean of this and a standard deviation of that. Okay, so what we're doing is we're comparing the reliable assay with the new assay. Maybe the new assay is less expensive or easier to run, or you just like it better but we got to know if it gives the same results in order for other people to be able to use it. All right, so let's see what we got here. And I gave us a table here. This is one way you can plan your work. So let's just put that right here. All right, so if you look at and up at the reliable method, you count and say 4 replicate measurements. Okay, so that tells me, just because I'm going to need it, the degrees of freedom is 1 less. Okay, and in the new method, 1, 2, 3, 4, 5. 5 replicates. Degrees of freedom is 1 less. Okay, so we've got the means, we've got the sample standard deviations, and we're good to go. All right, so first thing I want you to do is I want you to calculate the F statistic. So pause the video, calculate that, and come on back. All right, welcome back. So the larger standard deviation, as its variance goes in the numerator, the smaller one in the denominator. So that gives us 3.58 squared divided by 2.8 squared, 1.6, and we'll keep the 3. Okay. If you look up the reference value in the table, for degrees of freedom of 1 and then 3, you get a value of 9.12. So you can see that the calculated value is less than the table value. Okay, so I want you to write me a sentence. Answer the question. Pause the video, write a sentence, and come on back. All right, welcome back. So I said, since the calculated value is less than the reference or table value, these standard deviations are not statistically different. So we can have 95% confidence that this difference that we see in the sample standard deviations is only due to random error. It's not due to some real difference between the two data sets. All right, can you be 95% confident that your method produces a result different from the reliable value? I want to change these words around. Can you be 95% confident that your method produces a result that's the same as? Because we want to know, is the new method as good as the reliable older method? All right, so what we've got to do is we've got to set up a pooled standard deviation and calculate a t-value. All right, so in our plan the work strategy, we've got these guys, which we'll use to make a pooled standard deviation because they're not statistically different, so we can put them together. Go from there to the calculated value of the t statistic, and then we can compare with the table value. All right. 1, 2, 3. All right, so the first thing I want you to do is I want you to pause the video and I want you to calculate the pooled standard deviation, but let's set it up first. Put our information into the equation that you've got above there. Let's see, 3.58 squared times 4 plus 2.8 squared times 3 . And you can do the 5 plus 4 minus 2, or you can just do the 4 plus 3, and that will get you to the same place. It's just the total number of degrees of freedom. All right, so pause the video, run that calculation, and come on back. All right, welcome back. I got 3.27. Is that what you got? All right. So now that we've got that, we're ready to do the t-statistic calculation, the difference between the means, the absolute value of the difference between the means, divided by this pooled standard deviation, multiplied by this product of the two counts divided by their sum, take the square root. All right, so I want you to put the data into this one and then do the calculation. All right, welcome back. So we got 116.4 minus 111 divided by this 3.27. Let's give it some brackets here. And then I've got 5 times 4 divided by 5 plus 4. No, let's not do that. Let's just go ahead and do the square root symbol. And I got 2.46. Is that what you got? I'll give you a minute since I was a little off screen. All right. If you look up the table value at these degrees of freedom, set 1 has 4, set 2 has 3, then that reference value is 2.365. All right. So now we're finally able to compare the data sets themselves and say something about whether they are statistically the same or not. All right, so pause the video, write a sentence, and come on back. All right, welcome back. All right, so when I compared the table value with the calculated value, I can see that my calculated value is bigger. So since this one is bigger, I'm 95% confident that these two sets of results are statistically different. And that means that the results from the new method are not the same as the results from the established method. And then you'd have to go back to the drawing board. But that would be an important thing to know. All right, so this is the basic story about how you use students T to evaluate the means and ultimately the whole of 2 different data sets to see if they are statistically the same or not. If you have any questions, please send them to me.